All right, boys and girls, moms and dads, this is Teacher Chang giving you another lesson on quadratic functions. Today we are going to take a look at how to graph a quadratic function in both its vertex and standard forms, as well as stating the many different properties found just by looking at its graph. So let's go ahead and get started, and we'll take a look at one written out in vertex form. Now you got to be able to recognize that this is in vertex form. And to recognize how that is the case, well, we need to know that vertex form has that format y is equal to a times x minus h squared plus k. So when we have an equation that looks similar to this format, where a is a number, h is a number, and k is a number, we know it's in vertex form. Now, right away, I can see that my a value is -3. The h value is going to be at -1, and the reason why h is -1 is because the minus h takes our +1 and turns it into its opposite. So anytime it's inside that parentheses, that h value has to be the opposite value in the equation. Now the k value is going to be our 3. Now, the reason why it is called vertex form is because we can right away see what is that vertex. And that vertex is going to be our h and our k values, -1, 3. So that's the vertex at -1, 3. So I'm going to go ahead and graph that point at -1, 3, which is located right over here. And then I'm going to go ahead and take my ruler and just draw a straight line going through that vertex. So I'm going to go ahead and draw this straight line going straight through that vertex. And the reason why I'm drawing that line is because this line happens to be our axis of symmetry, also known as the line of symmetry. So I'm going to go ahead and label this as our axis of symmetry, our AOS, or you could call it the line of symmetry. And this is going to be located when x is -1. So I know what the line of symmetry is. The line of symmetry, or the axis of symmetry, is x is equal to -1. Okay, so I got pretty much most of the information that I need. I just need to find out, well, what is the rest of my graph? Where is the rest of my graph? Well, to figure out the rest of our graph, we're going to go ahead and use something that I call the 1-3-5 trick. That 1-3-5 trick means that I'm going to take 1, 3, and 5, and we're going to take our a value, and that a value we stated earlier is -3, and we're just going to multiply that 135 with -3. So we multiply it with that a value, and that's going to give us -3, -9, and -15. Now, what does that tell us? What do we do with this -3, this -9, and this -15? Well, since we know where the vertex is, that -3 means that I'm going to go down 3 and then over 1. That -9 means to start where I left off, and I'm going to go down 9 more and over 1. So I'm going to go down 9 and over 1. Now the next step would have been down 15 and over 1, which I can't fit into my graph. Now, because we have this line of symmetry at x is equal to -1, that means I should have a point directly on the opposite side. So I know that I have a point here and here. Okay, now that I have these points, we could go ahead and draw a parabola. So our parabola is going to look something like this. We're just going to sketch it out the best that we can. And we can see that our parabola is opening in a downward direction here. Now I already know, or I knew beforehand, that my graph would open in a downward direction, and the reason why I knew that is because our a value had a negative sign right in front of that 3. So when a is negative, it's got to open in a downward direction. All right, so what we want to do is we want to figure out, well, what are these other properties? We figured out the vertex, we figured out the line of symmetry, now I need to figure out the rest. Now the domain is basically reading the graph from left to right. And when we take a look at our graph here, we can see that our graph will go on forever to the left, and it will go on forever to the right. If we extended it on, it'll keep going forever to the left and forever to the right, which means that if we read it from left to right, that means it's going to start off at negative infinity because it keeps going forever to the left, and it's going to keep moving on towards the right forever as well. So that's going to go on forever to positive infinity. So the domain is going to be from negative infinity to positive infinity. Now I'm putting parentheses around here because the parentheses tells us that we cannot include that infinity. We can't put a closed circle on infinity. So that's what a parentheses means. Can you include it, or can you put a closed circle? Now another way to write negative infinity to infinity is just stating that they're all real numbers. Now the range, instead of from left to right, what we're going to do is we're going to read the graph from bottom to top. So at the lowest point of our graph, well, the lowest point of our graph are these arrows. And these arrows means that it's going down forever at negative infinity in terms of y. But our graph, the highest point of our graph is located right over here. And that highest point is located when y is equal to 3. So the range, again, is from bottom to top, is going to start off at negative infinity. And again, since I can't put a closed circle on infinity, I'm going to put a parentheses with that negative infinity. And that keeps going up until I hit the peak of my graph. And the highest point of my graph is at 3. Now, I do have a point on that 3, so I am going to go ahead and put a bracket around it. Now, the bracket means that it does include that 3. So I do have a closed circle on that 3. Now, the next one is continuity. Continuity is just asking you if that graph is continuous. In other words, can I trace this graph without lifting up my pencil? And yes, that is the case. So I can go ahead and trace this graph without lifting up my pencil. So there is continuity. The next point is the max or the min. So I want to figure out, well, do I have a maximum point or a minimum point? And when you do that, we're going to be looking at that vertex. So here's our vertex, and we could see that that vertex is the highest point of our graph, which means it is a maximum. So we have a maximum value, and that maximum value is right here when y is equal to 3. So I'm going to write down y is equal to 3 for the max. And if I have a maximum in a quadratic, that means I cannot have a minimum. So you can write none or does not exist. DNE for does not exist. Now the x-intercepts, if we're lucky to have something like this here, we can see that our x-intercepts are the points where it crosses the x-axis. Now it crosses the x-axis in 2 locations. The first one is on this left at -2, and the other one is located at 0. So we have 2 x-intercepts. One is going to be located at -2, 0. That's the first ordered pair. And the second one is going to be located at 0, 0. The y-intercept is the point where it crosses the y-axis. And if we take a look at our y-axis, it crosses right over here, which happens to be the same point as our x-intercept. So we do have a y-intercept also at 0, 0. So sometimes, not always, but sometimes our x and our y-intercepts can overlap. The line of symmetry we already found that x is equal to -1, and all we want to do now is to figure out, well, when is our graph increasing and when is our graph decreasing. So the interval means from what point to what point is our graph increasing and what point to what point is our graph decreasing. Now we always read a graph just like how we read a book. So if I take a look at a book, I'm going to read a book from left to right. So if I take a look at this graph, and I'm reading this graph from left to right, starting all the way to the left, I'm going to go in an upward direction. So we could see right over here, from left to right, if I go from left to right, it's going in an upward direction here. That means the graph is increasing from left to right. It's going in that upward direction. So left to right, it's going in that upward direction here. Well, where does that upward direction begin? Well, that upward direction begins at this negative infinity because it's starting on the left side. So if we take a look at the left side, it's starting all the way to the left, and it keeps going in an upward direction from left to right up until it hits this line of symmetry. So again, if we take a look at that line of that line of symmetry here, starting all the way to the left, it's going in an upward direction, and it keeps going up right until it hits that line. So that means it's starting at negative infinity, and it keeps going up until it hits that line, and that line is located at -1 when x is equal to -1. And as soon as it hits that line, our graph starts to decrease. We can see that right over here. So our graph starts to decrease. So once it hits that line, our graph is starting to go in a downward direction. So since it's going in a downward direction, we're asking ourselves, okay, well, where does that begin and where does that end? Well, it begins to decrease starting at -1, where that axis of symmetry is. So it starts at -1, and it continues to decrease. It continues to decrease until it hits infinity. So again, if we read the graph from left to right, it starts at -1 and continues to decrease forever towards the right. So from here to here, reading it from left to right, it's going in a downward direction. Now, at -1, there's a reason why I have parentheses around the -1s for both the increasing and the decreasing values. The reason why is because at -1, it is neither increasing nor decreasing at that point. So at that point, it's a turning point. It is neither increasing nor decreasing. So there's our vertex form. So let's go ahead and take a look at another one in our standard form. Now, our standard form will require a little bit of work here. Now, the nice thing about standard forms is that we know what our y-intercept is. And our y-intercept is always going to be that last value here, this value right over here. So our standard form, we need to know, well, how do I know it's in standard form first? So we know it's in standard form when it has that format y is equal to ax squared plus bx plus c. So a, in this particular case, is equal to -2, b is -12, and c is at -16. Oh, forgot the negative sign, so -16 here. Now, when it's written in standard form, that c value is always going to be our y-intercept. So I already know what that y-intercept is, and it's unfortunate that I can't fit that y-intercept in our graph here, but I could go ahead and write it down in one of our properties. So that y-intercept is going to be at 0, -16. So I would put a point somewhere down here if we had that -16. So it's somewhere around here. We're not exactly sure where that is. Okay. Now, when I go ahead and figure out my vertex form, that's going to require a little bit of work. So we need to figure out, well, what is that vertex? We want to go ahead and use that formula for our axis of symmetry. X is equal to -b over 2a. Well, we know what b is. b is -12. So a -12 means +12. So two negatives is going to make it positive. And that's going to be over 2 times a, and, well, a is -2. So if I go ahead and do the math here, well, that's going to end up being 12 over -4, and 12 divided by -4 is -3. Now, that's our x value. So our x value is going to be -3. And again, I stated earlier that this is our axis of symmetry, also known as our line of symmetry. X is equal to -3. So I'm going to take my ruler, and we're just going to go ahead and move that ruler over to -3 on the x-axis, and we're just going to go ahead and draw a line here. And again, that line represents our line of symmetry or our axis of symmetry. Now, we stated earlier that our vertex has to go through that line. It has to go through that axis of symmetry. So to figure out, well, where our vertex is, all I got to do is take this x value that we just found, and we're just going to substitute it in to our x values in our equation. So I'm going to go ahead and plug it in right over here and right over here. So I'm going to recopy that equation here. I'm just going to move this over to the side. So I'm going to go ahead and recopy that equation. And when I recopy that equation, anytime I see that x, I'm going to replace it with that -3. So we have y is equal to -2 times our x that we found, which is -3, squared, minus 12 times -3, and then we have our minus 16. So all we did is we substitute that x value into our equation. Now some of you guys are asking, well, before it said f of x. Well, f of x and y, those are going to be the same. So anytime you see an f of x, that's the same thing as your y values. So we're just going to do the math here. If I go ahead and take a look at this first part, -3 squared is 9, and -2 times 9 is -18. -12 times -3 is going to give us a positive 36. And then we have our minus 16. So if I go ahead and combine all of those, that's going to end up giving our y value. -18 plus 36 is positive 18, and 18 minus 16 is going to give us 2. So there's our y value. So what we can see here is that the x and the y values together will give us our vertex. So now I know my vertex is located at -3, 2. So I'm going to write that right over here, -3, 2. So there's our vertex at -3, 2, which is located right over here. Now to figure out our other points, once again, I'm going to do my whole 1, 3, 5 trick like we did in the previous problem. So I'm going to go ahead and do our 1, 3, 5. But this time, I notice that my a value is -2. So I'm going to go ahead and take that -2 and distribute it with the 1, the 3, and the 5, giving me -2, -6, -10. So that tells us where to go from our vertex. So from our vertex, I'm going to go down 2 and over 1. From this point, I'm going to go down 6 and over 1. And our next step would have been down 10 and over 1, which we can't fit. And once again, because we have this line of symmetry, I do know that I should have a point over here, and I should have another point right over here. Okay, so now that we have this, we can go ahead and draw our graph. So here's our parabola. It's going to go in again, a downward direction, and the reason why it's going in a downward direction, just like before, we look at our a value, and if our a value is negative, it's going to open down. If a is positive, it's going to open up. Okay, so we have this, and we just need to fill in the rest of our properties. So we got our vertex at -3, 2. We want to take a look at the domain, and the domain for these parabolas is always going to be all real numbers. And the reason why, it's going forever to the left and forever to the right. So that's going to be every number possible. Now the range, again, it's from bottom to top. Well, if we take a look at the bottom of our graph, it's going down forever. And that's what these arrows means. It's going down forever. And the top of our graph is right over here at y is equal to 2. So our range is going to start off at -infinity because it keeps going down forever. And the top of our graph is going to be at 2. And it does include that 2. So I'm going to put a bracket there. There will always be continuity with these quadratic equations. So that's going to be yes. And again, we ask ourselves, do we have a maximum or a minimum value? So in this particular case, if I take a look at my vertex, which is located right over here, that's the top of our graph, which means we have a maximum. So our maximum is going to be located at y is equal to 2. We look at that y value. And because we have a maximum, there is no minimum. And then we go ahead and take a look at our two x-intercepts. So if we take a look at the points where it crosses the x-axis, it crosses right over here at -4. I'll change the color here. So we have one at -4, and then we have one at -2. So our two x-intercepts are going to be at -4, 0. And our second one is going to be at -2, 0. And finally, we have our increasing and decreasing intervals. Now, if we read the graph from left to right, we can see that the left side is going in an upward direction. So from left to right, it's going in an upward direction. It's increasing from left to right. And it keeps increasing up until I hit that axis of symmetry. Now, remember that axis of symmetry is located at -3. And we started on the left, so that's from -infinity to 3. So it's going from -infinity to 3. That's the interval when it's increasing. So I'm going to go ahead and write that out as our increasing interval. So our increasing interval starts at -infinity, and it goes up until 3. Once it hits that 3, it's no longer increasing. Now, on the other side, the graph starts to decrease. So starting at -3 and going towards the right, our graph starts to decrease. So it starts at -3 and it keeps decreasing forever towards the right until infinity. So it's decreasing from -3 to infinity. As we read from left to right, our graph is decreasing starting at -3. I forgot the negative sign over here. So it starts at -3 until infinity. And we could see that our increasing and decreasing intervals, they look very similar. It's just reversed. So the increasing started from -infinity to -3. The decreasing went from -3 to infinity. All right, so that's how you graph your vertex form and your standard form, and that's how we check out the different properties that we found just by looking at the graphs. I hope this helped out, and if you have any questions, make sure you send me a comment.